All right, now we're going to look into how we can leverage Airflow to implement a model drifting pipeline that's going to implement a very simple ETL, an ETL pipeline that's going to go grab some data and run some ROC metric on top of this data in a automated, scheduled way so that we don't really have to run that manually every time we're wondering if our model is drifting or not. So how would we do that? Well, if you have access to the material, you should head over to the material for this course, which you can download online, whether you're watching on YouTube or on Udemy. Just go ahead and grab the material that is in there, look at the comments or look at the general instruction of the course, and you should see 4 files that we're going to need for this to work out. First of all, we're going to need a Docker file in which we are going to install Airflow so that we run Airflow not on our local machine, but as a containerized application inside of our Docker container. That's going to be very useful to replicate what we do afterwards and deploy all of this stuff online if we want to do so. We're also going to need a small Docker Compose file. Instead of dealing directly with Docker, we can launch and manage the Airflow service that we create here directly from Docker Compose. It's a convenience that's pretty useful, and we're going to be using it. And then finally, we have 2 more files. We have a model drift file and a model drift DAG file. The model drift is basically where we're going to lay out all the logic that we need so that we can have a pipeline that can do what we want to do. This pipeline can be arbitrarily long or complicated, or it can be very simple. Here, the pipeline that we're going to define is 2 very simple tasks. The first task is going to be hey, go ahead and fetch some data. And the second task is going to be evaluate some ROC score on this data. That's what we're going to use to evaluate whether a model is drifting away or not. And then once we have these 2 tasks laid out, then we can head out to the model drift DAG, because this is exactly where we're going to schedule our processing to run. I just want to mention again, for everything in this course, this is not an introductory course on Airflow. As always, if you want to understand how Airflow works, you should definitely check out the documentation. Anything from the tutorial to the quick start to just reading a little bit about it, everything is going to do a better job than me at explaining to you how this tool works. What I want to do is to show you how this is used in a real production context, right? So that you see how this is used in real life, and so that you can see where you should focus your attention on, right? So again, as always, if you have access to the labs, you can just follow what's going on here. It's always going to allow you to get up to speed with what I do here. I want to show you what you should be able to do once you have gone through the lab. I want you guys to do it at home, because the more you do by yourself, the better it is. And so once we come here and we look at our Docker file, essentially what we do in this Docker file is we create a new container from Python, right? We just say hey, create a container with a Python runtime and put all of the folder in it. We call this folder Bolot. We could call it anything, just MLOps or whatever it is. Just put stuff in there and make sure to copy also the credentials. The credentials are basically the Google Cloud credentials, so that we will be able to access the Google Cloud storage from the container where we are running the Airflow application. So make sure that you put your credentials inside of your container as well. Put in your requirements so that you can install all of the requirements. And this is basically looking inside of MLOps, grabbing the requirements and making sure that our container is going to have access to all of the dependencies and libraries that's useful for this course. And then we follow just a bunch of Airflow setup that happens basically based on how things are configured in here. We just configure them inside of the container so that we have the Airflow running in there from the way that we pass it the Python path, where we set up the Airflow home, a bunch of configurations that are useful in here, just saying where the Google application credentials are so that we're going to be able to access Google Cloud Storage and things like this. And then we run pip install Apache Airflow so that we install all of the Airflow library, and we just install Nano. That's not very important. And we just launch Airflow in standalone mode. We just launch the server of Airflow. And because we have defined a Docker Compose file that basically goes and create basically this container here on demand, basing the creation on the Docker file that we have defined here, making sure that we can have access to port 8080, mapping the volumes so that all of the content that is found in MLOps is also mapped directly into Balot. Whenever you create like a new file inside of your Docker container, you have this file that automatically creates in the MLOps folder as well. And we also map this Airflow local folder. We also map it so that everything that we do inside of the Airflow folder of the container is going to be in here as well, right? So you're going to see that Airflow is going to store a bunch of files in here as well. And we just keep that true so that we're going to be able to log into the Docker container, and that's it. And we create a .env file. It's not very important, to be honest. But anyway, so now that we have this defined, we can basically do something like docker compose airflow. This is going to be the name of our docker compose file here. Airflow is basically creating a database where it's going to keep all of the internal representation of the data that it needs, all of the DAGs, all of the information of the actions that are taken, let's say, through the UI and things like this. And so now what we have here is we have an Airflow standalone server up and running with a web server that allows us to do a lot of manipulation. And we have here the login user, the admin. So essentially what you can do now is we can head over to the UI, and through the UI we can log in as admin, and we can insert the password so that we can start accessing basically the UI here. Well, straight out of the box, basically Airflow screams at us and say a bunch of warning, right? This is very yellow. It's pretty scary. Basically what they're saying is like, hey, do not use a SQLite database in production. You should use like a real Postgres or MySQL database in production. Like everything, all the actions that we take and all the tracking of the DAGs that we're gonna see right now, all of this stuff needs to be persisted in a database, and SQLite is definitely not suited for that. We're also using a sequential executor, so essentially we don't really parallelize. If we run processing, if we run DAGs tasks, then we don't really parallelize it. We just run everything sequentially, and it's also not very great in production. But for now, it's good enough to at least show what's going on and show what we want to do to investigate the model drift. And it kind of makes sense that Airflow tells us that, right? Because if you look at the model drift pipeline that we want to run, and if we look at the processing that we want to do some, well, it's not a huge amount of processing, but it's pretty significant. And here, in our case, we're going to have only 2 tasks or like 2 processing units that we're going to run, but you might end up with tens and hundreds of tasks that are basically running every day. And this is exactly where you want to start parallelizing the work that you do. But don't worry about it too much. For now, we're really going to focus on the functionality, and we're really going to be fit for purpose here, really focusing on trying to do what we want to do. So what is it that we want to do? That's a good question that we need to answer. And why is it that we need Airflow to do that? So what we want to do essentially now is we want to go to our production model, retrieve the currently deployed model that is in production right now, and we want to grab a bunch of new data. This is feature store path. This is a bunch of new data. It's called feature store drift. This is new data that has been generated by deploying this model in production and just having a bunch of people playing with this model, just playing online, like the actual game of Balot Manier, just really like playing real games. Basically, by playing these real games, what these people have done is they have generated new samples of data where our model was playing in real life, and we can use this new sample of data to retrain our model, or at least to make sure that we are not performing worse than before we have deployed the model. In other words, we want to evaluate whether there has been any drift that has occurred with our model. And the way we're going to do that is we're going to do that with 2 tasks. First of all, we're going to get the feature store. This new feature store, maybe feature store is not the best name for it, but essentially what feature store in this context means is it means new data, a new data that contains features, predictive variable, like how much, like what was the scoring, and new data that has been generated through people playing with it. And now what happens is that if we take this new sample of data and we use our prediction model to predict what is the expected reward based on a bunch of different features, now what we can do is we can compare the labels, the actual labels, because we know from this new feature store here, we know what is the real answer. We know who actually won the game. So if we use this model here to predict on this feature store, and we afterwards we compare the predictions with the actuals, then we will have an idea of whether our model, our production model, is still suited to play in production, to play against people. Or maybe did people become better at the game, and so our model is not good anymore at playing against them, and we're going to need to retrain this model. This is exactly what we want to do in this model drift pipeline. All right, so what we're going to do here is we are going to set a base threshold of 0.5. We're going to create our target, and we're going to say that the acceptable ROC score, the one that we're happy with, if we were to let our production model keep running in production, we would want to have at least some kind of ROC that is at least better than 0.75. We are accepting a little bit of drift. So if our production model performs worse than 0.78 minus 0.05, then we're still going to accept it. We're not going to retrain our model based on this small drift. But essentially, this is what we want to do. First of all, we want to grab the feature store, or like this new feature store data. So essentially what we do is we are going to grab some new synthetic data. This is newly generated data from people playing with the platform, people interacting with the game, playing new hands, and therefore getting it to the end and generating a final score by playing like a whole hand. And so by playing, they basically generate like a new sample of data. And essentially what we're going to do is we're going to collect what we collected new sample of data into this file here called synthetic data contract. And we're going to see whether our production model is still performing well when it has to predict whether we're going to win the game or not on this new data that it hasn't seen before. And fundamentally, if the models still perform with an adequate level of performance, like adequate level of precision and recall and things like this, then everything is fine and it doesn't suffer from any drift. But if we see that we're consistently performing worse on this synthetic data by predicting who's going to win the game and comparing the actual labels, because this is new data that people have played, so we can see whether they've won or lost the game. If we're consistently doing worse at predicting who's winning the game here, then we might be suffering from some kind of drift. So we're going to grab this data from our Google storage environment. You can also just grab it from your local environment, wherever you want. And we are going to store this data as a feature store path. We're going to store this data in our new feature store. We're going to call it the feature store drift. This is going to be the features that are built from this new data, just to evaluate whether there's a drift or not. This is why we call it like this. And essentially, we're going to grab our model. We're going to use our model to come up with predictions on top of this data. We're going to check the precisions, the recall, and then essentially what we do is we set up a base ROC score. This is the score that we accept here. We want our production model to be at least generating a 0.78 ROC score on this new data that it hasn't seen before. And we are willing to tolerate a little bit of drift, like a little bit of lower performance. If we go down to like 0.73, 78 minus 5, then essentially we're not going to get crazy and really like retrain the model yet or anything. So we're going to accept a little bit of drifting here. And this is exactly what this pipeline here does. Essentially what we do is we read this new data, we run the processing pipeline just like we've done before with the actual feature engineering that we have done the first time that we want to train the model. We just run this processing pipeline so that we have access to the new feature, and we save these new features online. We store them in our Google storage space. And be careful, this is just a bunch of new features, and we should actually call that feature store drift. This would be a little bit more precise. Feature store drift. Feature store drift would be a better name to save this data here. And essentially, once we have done this part here, once we have generated new features, what we can do is we can go ahead and evaluate the ROC of our production model on these new features. So we can get our production model. This is what we've seen. We're just doing a bit of interacting with our cloud storage environment, and we're just retrieving the production model out of there. And essentially what we do is we get access to this feature store. Careful, this is actually the feature store drift. This is a better name here. I'm going to use it. Feature store drift, just so that it's like 100% clear that this feature store is not the same feature store as the one we use to train the model the first time. This is a feature store composed of new data to evaluate whether there is some kind of drift or not. So I prefer to be very explicit here. Essentially, we generate new predictions on this feature store, and we just do something very similar to what we've done before. We just create a flag that says 1 if we have a prediction that's above the base threshold, or otherwise 0, and we compute the ROC score of this new data by comparing the predicted with the actual, is what really happened. And this score here, if it's not above the minimum ROC that we are willing to accept, then basically we raise some kind of failure. We just say like, hey, the current ROC is lower than what we want. The drifting of the model is below the acceptable threshold. Retraining is necessary. And that is exactly the pipeline that we want to set up. We want this pipeline to run. And so you might be wondering, well, this is all well and good, but why don't I just run this script like I've run other things before? I've run all of the pipeline so far manually. I just launched the training either in my local environment or in a virtual machine. This whole course has been me running script like this out of my local environment, just like running a bunch of things. So what is different here? Like, why don't I just run this? And you're right, like I could be running this model drift pipeline, well, without any problems. I could just really run it. I encourage you to do so. In fact, this is a very good thing to do. You just run it manually to see if it works or not. But things become interesting when you realize that this is not something that I just want to run once or that I just want to run sporadically, like whenever I feel like it. This is actually something that should really be running very often, as much as I can. Well, reasonably, of course. I don't need to run this script like every 10 minutes, like probably things are not going to change too much every 10 minutes. But I still want to introduce this idea that I want to start running the script on a fixed schedule without me intervening here and reminding myself to run things. Like I don't want to put a reminder and say like, run it like every Thursday or every Friday or whatever. Like I just want to be able to run that on a weekly schedule, and I want to be automatically notified if things go wrong. And obviously this is a small example and this is very illustratory, right? Because it's not a huge amount of trouble to run that manually. But imagine that you don't have like just one pipeline like this, but you have hundreds or thousands of pipeline with a lot of different models that need very different schedule of runs in terms of evaluating the drift. Well, it becomes apparent that we need this scheduled approach here. And this is exactly what Airflow is very good at. Airflow is very good at looking at one of these pipeline, looking at one of these scripts and scheduling them on any schedule that might be suiting for our use case. For instance, in our case, I would want this model drift to run on a weekly basis. Like every week without me doing anything, I just want it to run. And if something goes wrong, I just want the program to notify me, say something, just raise an alarm or something like this. And this is really the power of Airflow. This is where things are going to become interesting. We're going to start defining an Airflow DAG that is just going to be a directed acyclic graph, just like a graph of how things should run, kind of like a sequential graph of what should run. And what should run is, first of all, this task, and when we have generated the new data, then we should run this evaluation. This is sequential. This is why we need a DAG in the first place. We need some logic in there that allows us to specify the program that first we want to run this thing, and then when this thing is run, and we have the new data generated, then we want to move over the computation of the ROC. And this is exactly what we're going to be able to do with Airflow. We're going to be able to set up a DAG object that we're going to call model drift. And this DAG basically is going to take a bunch of values. Like first of all, it's going to take as a parameter some kind of email. Like this is an email of whoever I want to notify if something goes wrong. Like I just want to send an email to, well, myself in this case, saying like, hey, something went wrong, just like notify myself. And I want to have this DAG run on a weekly basis. This is how I'm going to schedule it. I'm going to schedule it on a weekly basis, and it's going to run like every Monday or whatever I want. I'm going to start the run of this DAG on today. So as soon as I deploy this DAG, it's going to start running and it's going to run on a weekly basis. And essentially what I'm going to define is I'm going to define two wrappers, two Python operators. Again, like please go back to the Airflow documentation if it's not very familiar with the way to do these kind of things. But essentially what I'm doing here is I'm saying every week, whenever this DAG pipeline runs, first of all, what we're going to launch is a Python task, a Python processing that is going to call this generate feature store, and we don't really need to give it any parameters. We're going to launch this generate feature store, which is essentially what we've talked about, just accessing this new data. And then what I am going to do afterwards, like when this has worked, when we have generated successfully, as we can see here, trigger rule all success. Whenever something works, then it triggers the next one. Well, afterwards, we are going to create a new task that our pipeline is to take care of. And this new task is basically evaluate ROC task. It's kind of like a wrapper around just calling this evaluate ROC. Obviously, there is a bunch of more interesting and more complex stuff that we can do with Airflow, but this is already a fully functioning pipeline that we're setting up. And essentially what we're doing here is we're saying, okay, first you run the feature store task, and once this is done, once this has completed successfully, then we can run the evaluate ROC task. This is exactly what we're doing here. And once we have defined the model drift tag, basically what we can do is we can take it and we can put it inside of the Airflow folder that Airflow has created for us. And remember when I said that Airflow was going to populate this folder with a bunch of Airflow things? Well, it's basically what it did here. It created like a file where it keeps tracks of what PID the web server is running on and a bunch of other stuff like the admin password and things like this. It's not very important, but the only thing that's important is that we put in there, in the DAX folder, our model drift, and it's actually the same file as what we keep ourselves so that we can version track. It's kind of like the same file, it's just model drift thing. And essentially, once we have done that, then Airflow just automatically looks into this DAX folder, just looks whether there's any DAGs that is defined, and if there are any DAGs that are defined, then it kind of like load them in the UI, and on the UI, we can start interacting with it. We can do a bunch of stuff, like we can look first of all at the DAG itself, we can look at the two tasks that have been defined, and if you notice, then this is just feature store task, it's just a name that we've used to name our task. This is just a name that we've used here. And essentially, we're going to be able to look at a bunch of like interesting data, like how much time it takes to run this task, how many tries did we take, what is the underlying code that's populating those DAGs, what is the underlying code that's running these DAGs, and this is very similar, as you can see here. Well, it's not very similar. In fact, it's exactly the same file, basically. And so, all in all, what we want to do now is we want to test that this pipeline works correctly. And the way that we're going to do that is we're just going to come here and we're going to unpause this DAG. We're just going to like trigger it manually. Of course, if we were to deploy this Airflow environment in production and we were to enable this DAG, then this would do exactly what we ask it to do, which is run this set of tasks on a weekly basis. So on a weekly basis, just evaluate basically that the production model is not drifting away by predicting on new data that it hasn't seen before and saying that it's generating decent performances. That is exactly what the DAG would do, but now we're just testing it, so we're like imposing it, and we're just going to see whether it runs properly or not. So we can see that as we have launched the pipeline here, we can see that the first task here is being scheduled to run. So we have triggered a manual run of this first task, and essentially Airflow doesn't do any processing itself. Airflow is just a scheduling tool. So the actual processing, like where is the processing happening right now? The processing is not happening in Airflow. The processing is actually happening in the environment where we are hosting the code. And where is it that we are hosting the code? Where is it that we have launched the processing? In our local computer for now. Well, of course, we've created a Docker container, so it's happening inside of the container, but everything is still happening on our local computer here. And so the processing is, like the actual cores that are running these two tasks is the local computer. If we were to run this container on a virtual machine in the cloud, then the processing would be happening in the virtual machine in the cloud. Airflow is just a scheduling tool that allows us to say how should we run things. It's not a technology that runs the actual workload for you. That's very important to understand. And so now let's look at this here. Let's see if this is working or not. To see if this is working or like running or something fails, well, first of all, we can see that it's still running. We can see that if it were to fail, then we would probably have something that would say failed or something like this, or like maybe retrying, up for retry, because we actually said in the DAG that you should at least retry once to rerun the task. So at least it will retry once. But let's click on the task here, and we can look at a bunch of things, right? We can look at the instance, the logs. We can see what's going on basically by looking at that. So first of all, I can look at the instance, but it's not going to help me too much. What is going to help me is look at the logs. So if I look at the logs, I'm going to see basically if things are working properly or not. And I can see directly that as I look at the logs of the processing, right, I'm trying to do something very straightforward, like I'm trying to run this generate feature store. And as I try to run this processing here, something is telling me like, hey, key error, features, like something is going wrong. I can see that it tries to run this stuff very often and it doesn't really work. And then essentially what happened is that the task has failed. So now I can see that it failed because it's in red. And then this one is really trying to run as well. But this one is not even trying to run because the upstream failed. So this one failed. So this one is not even trying to run because it knows that there is no point in even existing if its upstream task hasn't run properly. So now we should really focus on trying to understand what happened to this feature store task. Why did it fail to run? And we have a big hint here, key error features. So as we try to read this synthetic data, we try to do something on this synthetic data that involves basically calling some kind of like feature key. And that is not great. Let's see. So if we remember what our synthetic data actually looks like, it should be called raw features, not features. So that's why it's failing here. So our run processing pipeline was not working. And so essentially like this was not working either. So this is a small mistake, but it's not very important to understand. Essentially what we're going to do now, this was good to have this failure because now we can see what happens when we fail. So now we've like fixed what probably was the issue here. And so now we have fixed what the issue was. And now we can head back to our Airflow environment and we can do something that's basically called a cleaning. So essentially we can go back to the graph. We can go to this feature store, and remember, we're just trying a bunch of things, so nothing too important is happening. But essentially what we're going to do here is we're going to go on the task that failed, and we're going to say something like clear. And when we clear this task, essentially what we're doing is we're saying like, okay, pretend that this task has not been run yet. That's what we're doing when we say clear it. And this is great because when you clear this task and you pretend as though it hasn't run yet, then essentially what Airflow does is it reschedules it. It just reruns it automatically. And this is amazing. We see that Airflow has rerun this task and everything seems to have gone very smoothly. Like if we go back to this task here, this task which basically reads some data, you might realize that I sneakily added a very small filtering here so that we don't use too much data and we go fast. But essentially, as we rerun this generate feature store, now everything has run perfectly. This is why we can see in the logs that nothing went wrong, that we just marked this as a success. And if you go back to the graph and you look at the graph, we can see that these features were stored work properly and it's marked in green to show that it worked. But now we have another issue. Now we see that the evaluate ROC task doesn't work. Let's look at this again. Let's go to the logs and let's see why this failed. Value error, input contains nans. Okay, so something wrong is happening. Let's see if we can correct that. Okay, so this was actually a minor detail. I just added a drop NA here just to make sure that there's null values as we read the data from the feature store path. Let's not focus too much on this, but let's really focus on Airflow here. And it's actually good that we had this error because now we can again see how we can deal with this. So now that we have done a bit of change in the code and we believe that our evaluate ROC is going to work properly, now we can go back again to the pipeline and we can say, you know what, well, this feature store task worked properly, right? So there is no need to clear it, it just ran. But this evaluate ROC task didn't work properly. So we're going to clear this guy here, and we're essentially going to say like, hey, just rerun this part of the schedule. And again, this is why Airflow is so important and so good and going to make our lives so easier. Because when things don't work our way and a pipeline hasn't worked properly, we don't need to relaunch the whole pipeline. We can just relaunch the problematic bits, like the part of the pipeline that hasn't worked properly, and that's going to allow us to make things much more efficient, that you don't always have to rerun like a huge pipeline when some small bits of the pipeline had issues. And I can see that we still have some issues on the evaluate ROC task. Let's see what's going on here. All right, very interesting. We go into the evaluate ROC task, and essentially what the evaluate ROC task does is what we've asked it to do, just raise an error, an issue, when the current ROC is smaller than what we should have, right? Like the threshold that we have defined. This is 0.78 threshold here. And essentially the task here has run, and the task has told us that, well, we precisely have this issue here. We have a current ROC on this new training data, on this new synthetic feature data that is around 0.66, and this is lower than the 0.73 that we require. And because this is lower, we conclude that the drifting of the model is below the acceptable threshold, and we might need retraining. So this has run once, but it's gonna run one more time just to make sure. This is why we have put in the DAG definition the retry, so that we make sure that this is not just random, it's really like something that's happening. And we see that after having run one more time, you again see that the ROC is just not up to standard. And this is why you can see that the evaluate ROC task failed. And so if we go home to our dashboard where we can see all of the tasks running, we see that something went wrong. And imagine that you just connect, let's say once a week, or you just ask Airflow to send you an email when things go wrong. Well, you would be notified now that your model has been drifting and that things are wrong, and that you might have to go back to your workflow to retrain your model and make sure that it's back to standard, that it's back to a level of performance that's acceptable for you. And so that's why Airflow is so powerful for you. Again, you can see like a bunch of interesting things. You can see how much it takes to run each part of the DAG. We can run at like when was the last time that we ran anything. We can look at a bunch of interesting things. But the most important part here is that Airflow told us that we should go back to retraining the model because the performance has been decaying right now. All right, I hope that you enjoyed this very small introduction on Airflow. This is the tip of the iceberg. You can do much more, and if you understand what has been happening, at least in this tutorial, then you're like already on the path towards understanding why Airflow is such an important tool for data engineers, machine learning engineers, and everyone who's working in the field. I hope that you enjoyed the tutorial, and talk to you soon.